Welcome everyone to another lesson on Khadija Academy. Before we start this lesson, hit the subscribe button, the notification bell, and the like button for the YouTube algorithm. Now let's go and start our lesson. So starting with the first method, open loop control, vector control, open loop control. In open loop control, we don't take any feedback from the output. We give the reference values to the controller and it will give us the pulses directly. So we have the voltage of point of common coupling and we have our static synchronous generator with an angle V and angle voltage V and angle phi. And we are controlling here the output currents. The output currents IA, IB and IC of the static synchronous generator that is corresponding to ID and IQ that can control B and Q. So ID and IQ are the output currents of the static synchronous generator. So how can I convert this into a control loop? So by logic, you can see that what is the power you would like to get? Okay, so power I would like to get is equal to root 3 over 2 VBCC ID, right? Or the ID reference, the current that I would like to get is equal to power needed, B reference needed, divided by root 3 over 2 VBCC or Vmax here, right? So if I take the reference power needed, what kind of power, how much per unit, or how many per unit, or how much per unit, 1 per unit, 0.5 per unit of power you would like. Okay, so dependent on this value, you will divide it by the constant root 3 over 2 Vmax, you will get ID reference. Similarly for Q, you will find that IQ reference will be what kind of reactive power do you need, divided by root 3 over 2 V max. So what kind of Q? Would you like to inject Q, making Q positive? Or do you would like to absorb Q from the grid? You would like to take reactive power from the grid, so make it negative. Or you would like to make it 0 and you would like to work at unity power factor. Don't inject and don't absorb any reactive power. All of this can be achieved by controlling ID and IQ. Let's translate this. So what you will see that if you take B reference and divide it by root 3 over 2 VBCC, you can see B reference divided by VG. VG here is our root 3 over 2 VBCC, as you will see right now. You will get the reference current. Similarly for Q, you will get IQ reference. Let's delete this. You will see this point. VG is root 3 over 2 VBCC, which is V max. Okay. Now we have the two reference currents. By doing an inverse Park transformation, we can convert from DQ to alpha beta, right? From DQ to alpha beta. Okay. From DQ to alpha beta, what angle you would like to get? I will use the angle theta, which is obtained from the phase locked loop, which we will learn about in the next lesson. So we will have currents that will be injected to our grid. Its angle will be the angle theta, which is the same angle to be synchronized with the grid, right? Must have the same phase shift in order to be synchronized with the grid. So theta here will be obtained from the phase locked loop. By taking the three phase voltages of the grid, we will get the angle theta. Okay, why angle theta? Again, if you remember, because when we select the angle theta for transformation, we make d-axis on VBCC, right? D-axis on the angle of transformation is the angle of VBCC, or the angle of the vector itself, right? Okay, so this can be obtained from the three phase. Using phase locked loop, we get theta, which is the same angle of transformation that will make d-axis on VBCC, right? As we explained in the previous lesson, okay? So by doing this, by using inverse spark transformation, you will get I alpha star or reference and I beta reference. By using an inverse Clark transformation, you will convert from alpha beta frame into ABC frame. So you will have a bunch of currents or reference currents that are needed to be converted into pulses to the switches of the inverter to achieve these currents that will also lead to achieve of these power control, active power control and reactive power control. Again, if these values are positive, it means that we are giving active power, giving reactive power, or feeding power to the grid. If any of these are negative, let's say P negative, it means that we are absorbing active power from grid. If Q is negative, it means that we are absorbing reactive power from the grid, okay? So I hope you now understand. In this technique, we are controlling current. Currents are converted into pulses using a current switching technique, which will be explained in the next lesson, okay? Okay, so we have our currents and we obtained them by using this control loop, okay? Thank you for watching this lesson. I would like to invite you to our academy, Khadija Academy Premium membership, which will help you learn more about electrical engineering. In this academy or in the academy membership, you will find that we'll have more than 100 courses in math, electrical engineering basics, power engineering career preparations. For example, we have electrical design, we have courses on electric circuits, power electronics, ETAB, MATLAB, solar energy, wave energy, wind energy, and much more. You can join our membership for just a small fee per month, or you can just have a lifetime access in which you will get all of current courses and classes, and you can have them forever. And not only this, but any new courses that will be created, you will be able to watch it for completely free. So what are the classes that I will learn in this membership? You will find different classes in electric circuits, you will find in transformers, magnetic circuits, machines, power electronics, load estimation, lighting design, lightning also design, earthing system, cables, generators, light current systems or low current systems, off-grid design, on-grid design. Very lots of classes and courses in different topics.